Hi guys!
So Mr. Logasa assigned us to find the distance between room to technical and technical to entrance, and we use meter stick for standard reference.
And regards with that, we also asked to find the resultant vector, unit vector, and inverse.
Good post-meridian, everyone. So we're assigned to measure the distance between the room and the technical to the entrance. So based on what we have gathered on the measurement, the room and technical has a distance of 39 meters. And also for technical up to the entrance, we've gathered a distance of 76.25 meters. We've used a meter stick as a standard reference. So we've asked to find the resultant vector, the angle, and the unit vector. So at first, we're going to find the resultant vector. So resultant vector has a formula of f1 squared. Putang ina, square root na pala. So we're asked to find the resultant vector, the angle, and the unit vector. So at first, we're going to find the resultant vector. Resultant vector has a formula of square root of f1 squared plus f2 squared. So our f1 value is 39 meters, and our f2 value is 76.25 meters. So substituting all the values on the given formula, which give us r is equals to square root of 39 squared plus 76.25 squared, which yields the square root of 1,521 meters plus 5,814.06 meters, which will give us the square root of 7,335.06 meters. And for the final answer, our resultant vector is equal to 85.64 and rounding it off, which give us 86 meters.
And now we're going to find the angle theta using the formula tan raised to negative 1 times y over x. And we're going to substitute the value, which y is 76.25 and x is 39. So the final answer is angle theta equals to 62.91.
So now, we will going to check if the R is correct. So, we will,
So now we will going to check if the results is correct. So we will use the formula sine theta is equals to opposite over result. So we will distribute the given value. So sine 62.91 is equals to 76.25 over the r. So we will multiply both sides by r. So we will cancel the r in the formula. So r times sine 62.91 is equal to 76.25. So we will get the sine 62.91, which is 0.89. So now, when we get the 0.89, we will divide both sides by 0.89 to remove the number in the result. So result is equals to 85.67 or 86. So now, we are going to use the formula of cosine if the sine is correct. So, cosine 62.9 is equals to 39 over r. So, we will multiply again both sides to cancel the r in the formula. And then we will get the r cosine 62.91 is equals to 39. So, we will get the cosine 62.91 first. So, when we get that, r is equals to 0.455 is equals to 39. And we will divide both sides by 0.455 to remove the number in the r. So, now we will get r is equals to 85.71 or 86.
So now we're going to get the magnitude of vector. So we will be using the formula magnitude of vector is equal to square root of v1 squared plus v2 squared. Our v1 squared is equal to 39 squared plus our v2 which is 76.25 squared. 39 squared is equal to 1,521 and v2 squared which is 76.25 is equal to 5,814.06. And that will lead to square root of 7,335.06 or 85.64.
Now let's solve for the magnitude of the unit vector. So the magnitude of the unit vector must be equals to 1. And magnitude of the unit vector is equals to square root of the first unit vector which is the 39 over 86 plus the second unit vector which is 76.25 over 86 squared. So square root of 39 over 86 squared plus 76.25 over 86 squared is equals to 0.9917. So the square root of 0.9917 is equals to 0.995 and we're going to round that off to 1. So the magnitude of the unit vector is right.